What we did yesterday, good day yesterday out on the field. Maybe some of you might be a little sore today. I know I am a little bit because we haven't climbed in a couple of weeks, but it feels good to get up there and stretch it all out. Appreciate all your hard work you did yesterday, and taking care of business basically. So good job to everybody. Just like we talked about day one, I don't know if we touched on it a whole lot. But what we'll do first thing in the mornings on video, and if you want to do it out on the field, we'll do a little safety presentation, a little safety video. I'm going to take care of it this morning for us. Next week, when we get online Monday, I'm going to start with my guys, and let me go back to my attendance. So, Jordan, I'm gonna go through the video today. I'm gonna show a video, and if you would you're the first one on my list in our class. Would you take care of Monday's safety meeting, please? And
Copy.
and guys, you can do this on anything, anywhere from safety glasses, boots, hard hats, safety, traffic, gloves, ladder safety, climbing tools, hand tools, knife safety, bucket safety. Guys, electrical flashes, um, anything to do with the industry, anything to do with safety, really. There's tons and tons of stuff out here for you to look at. Just go to YouTube and search, knife safety, and it'll bring up a bunch of stuff. And it may not pretend to align, but it may, somebody talking about how to use a knife safely. Traffic say whatever it is, whatever you want to do, let's do that. So Jordan, Monday, if you would, sir.
Sounds good.
I'm gonna take care of this morning's meeting. I got a little video since we started climbing yesterday. I'm gonna share my screen here. And what I like to do, and Professor Shoemaker does it too, we kind of let these videos play through, and we might stop it from here to there, but if it's a short video, we'll play it through. Then we'll back it up, and guys, and we'll have a little discussion on it, pick it apart a little bit, talk about some things, maybe what we see is going on wrong or what they might be doing right. So watch the video, and then we'll talk about it. You guys got my screen?
Yeah, I can see it.
Okay, guys, let me know if you can't hear it.
Hi, I'm Robin. This is Girlfriend, and I am going to.
Can y'all hear that?
Yeah.
Watch Vince do it. Seems pretty easy, so let's see how I do. First, he told me this is my safety climbing belt. Just hook it around and bam, like hooking into a roller coaster. All right.
Bam.
Okay. Lean back where you feel comfortable. Put your hands up and just quarter of an inch is all it takes.
That's all it takes.
Okay, you're okay. You're all right. Okay.
Okay, here we go.
It's all right. Okay, let's just work on our gap angle. We're going right in the quarter of the pole. I know everything's a little bit too big. Keeping that knee away from the pole. How about a little smaller step? There you go. Okay, now just lean back in your belt. Let's see how comfy you are. You can move that belt up. You're okay. You can move your belt up a little bit.
Right now?
Yep. Okay. Okay, let's lock that leg. That right one. Good. Lock it all the way. There you go. Okay, now just lean back. Lean back. There you go. Look at you. Stand there. 2 more steps. Now, you see your belt's got a little twist in it. Okay. Yeah, that's okay.
Should I rehook it?
Yeah.
Right now?
Can you lean in? Lean into the pole. Keep your right leg locked. Keep it away from the pole. See how your knees so close? There you go. Perfect. Look at you. Okay.
You guys working gloves.
You're okay. So you just unlatch that. You just give it a little spin there. Perfect. Yep. So it's going to match your other one. They're going to be facing out. Just so they can't inadvertently get opened on you. Perfect. Now with your hands, if you can just pull your belt up a little bit above waist height and lean back. How's that?
Perfect.
Perfect.
Step up a little.
Okay, now your right knee's locked, right? Okay. Now your step might be a little big, but let's replace your right foot, how it's locked, and let's just lock your left leg.
Leave the belt where it's at.
Yep. Now that's gonna bring your right foot out. So just leave your right foot and just step up with your left, keeping your knee away from the pole. Okay, and you can put your hands on your belt if it's easier for you. Okay.
I want to stab myself with this.
Now you see how your belt's falling down?
Yeah.
Okay, bring that up. Now just lean back in it. See your gaff angle, you're too tight. There you go. Lock that left leg. You're okay.
That's good.
Yep, lock your left one now.
How's that?
Good.
Man.
Okay, pull your belt up a little bit. That's where it's comfortable. Now just lean back. Lean back, trust it. There you go.
Keep right. You guys make this look easy.
Keep your left leg locked.
Okay.
Okay. Now your right leg is it's on vacation.
Oh yeah.
Right? How do
Not too bad either.
your feet feel? Okay. Can you pull your hands back to your belt? Look at that. Is that left leg locked? Remember, I have you on camera.
I'm afraid of this pole. I'm afraid it's gonna get on me.
Oh, the pole's fine. Well, it's been checked. Okay, you want to practice going down? Now your left leg's already locked, right? So let's lean in just a little bit to take the pressure off the belt, and let's bring the belt down. Perfect. Perfect. Now you can lean back with it just like that. It's not going anywhere.
How you like that?
That's fine. That's a good first step. Now lock your right one. Okay. And then come down to your left. Lock it. Good. Good.
I did
Not-
it.
not
Put your
bad.
feet up.
Very good. Very good.
That is how you climb a pole. Mexican style.
Okay. All right, gentlemen.
Those sure are pretty yucca plants, aren't they?
Yeah.
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 Is that where they're at?
Yeah.
Mhm.
Yeah. Guys, some of the same stuff that you all heard us telling you yesterday, somebody tell me some of the same stuff you heard right there.
Lock the legs.
Lock legs.
Make sure the angle of the buck slide is up above.
Okay. Gaff
Mhm.
angle.
Yeah. She's not using, and that's probably, I don't know how old this video is. She's not using a buck squeeze.
Yeah.
Yeah, it's like a leather.
Yeah, that's our old normal type of climbing belt right there.
Right. Yep. That's what when we did a little bit of free climbing, that's what we used. But yeah, they talked about, gaff angle, making sure your gaff's in the quarter of the pole, knees away from the pole. You heard them talk about that a little bit. You saw how when she was trying to take too big of steps and her knees were, right there close to the pole. Of course, locking legs, small steps, locking, like I said, a lot of talk about a lot of locking your legs back, and you're gonna hear us remind you guys of that as well, because technique is what really counts when you're learning to climb, so you can learn a really good technique for climbing. And that's a lot of stuff to kind of put in your mind when you're learning all this stuff. You got to remember to lock your legs, make sure your gaffs and you got the right angle, make sure in the quarter of the pole, right distance with your buck squeeze, all these things. But once you start doing it, as much as we're going to let you start doing it and climbing and all, it's just going to become second nature to you. So just as this young lady is doing in this video, and she's learning, and I mean, she's having a good time doing it. And that's really what we want it to be. We don't want it to be such a hard task for you. We want you to enjoy doing that, because I mean, Professor Shoemaker and I both, we talk about it sometimes that, if we weren't here today, that would probably be an indication that we really didn't like what we did when we started. And I really love my job. I love doing it. I love the climbing part of it when we free climbed especially. But the whole lineman, it wasn't just a job, it was a lifestyle. For me, it was you know, the best thing. I really loved it. So, and I want you to, and Shoemaker does too. We want you to love what you're doing. We want you to enjoy your climbing. Do not want to make it a really bad task, something that's going to put a bad taste in your mouth. And I'll say it one more time today. I know we're not on the field, but anytime if you feel like you're having trouble, come to us and ask us.
Right.
It may not be on the ground right now while you're learning, but things change. Like we said yesterday, when you start getting heights in there involved in it, start transitioning over the neutral, and you'll be up around a transform or cross arm, you know, working up there, and you might be a little unsure about what you're doing. Just say, hey, can you get up the pole with me and help me walk through transformer change out, cross arm change out? That's no problem. If that's what it takes, that's what we're here for.
Yeah. Yeah, I couldn't say that any better right there. I think we had some days Professor V would swap with me, or I'd work with him. And I think the longest I was out there on a pole and transformer changeouts was 6 hours.
Yeah.
6 hours on a pole, you know, and students just kept coming up to me.
Yeah.
That's what we're here for, guys. Don't think Shoemaker, well, it's good if you bring me a bottle of water or whatever, but yeah, that's what we're here for. And if we're tired, we'll tell you.
Yeah.
But and the other part right there, and I think I can't remember who I was speaking to, you know, linemen right now are considered first responders.
Right.
And they have got a lot of recognition in the past 5 years. There's a National Lineman's Day.
Yeah.
And you know, it's a, I don't know, put it, it's like a genre. It's a genre of employment. And I like the fact that people appreciate what we do. The lineman is, as far as a utility, is where managers say where the rubber meets the road. You know, we're the workforce of that utility. And it's, you get of course, a monetary satisfaction out of it, and you get self-pride satisfaction. I was thinking about it yesterday, and you guys climbing yesterday. We're going to do a yard tear down and rebuild out there. And when you get the rebuild done and you look back and you think to yourself, I did that. Me and, you know, 12 of the guys, we built this field. And I still drive by poles today that, and I'll find a picture of one that I've worked out by myself in a bucket. Well, when I say in the bucket by myself, and, you know, had a line truck operator and a grunt on the ground, and a supervisor that I drive by today and said, man, I did that. So I want you guys to feel the same way, pride in your work. Go ahead, Professor V.
Yeah. Guys, you got any questions about anything so far? About this video, about your climbing, about technique or anything?
I do have one question. Yesterday, Professor Shoemaker pointed out, like my gaffs, whenever I was putting them on, I had them on the right, or no, I had them on the wrong foot, I guess, but they weren't inverted in, they were inverted out still, but they were still backwards. So I figured out once I switched them, they helped me climb a hell of a lot better.
Oh, yeah.
Yeah, take your time on that part. Remember on the hook, so they've got LRs on them. So double check that. And, you know, it was your first day yesterday, all of you. If you don't think that you say, well, Professor Shoemaker is going to think I'm silly, if, you know, I'm going to joke, of course.
Oh, not at all.
You know, I'm going to say, hey, man, you don't know your left from your right, whatever. If you look at your tools, got my left, got my right, you know, good to go. You know, we're not going to hammer you on that stuff. Obviously, the buckle on any set of hooks goes forward. It points away from you. So that's a great indicator if you can't see that left or right that's stamped on those things. Sometimes they do get worn out.
Right. Any more questions, comments? Guys, just don't be afraid to speak up. Just if you got anything on your mind, want to talk about it, bring it up.
On that 30-foot pole, whenever you're getting up it, obviously it gets smaller. Do we adjust the buck slide once we get up to the top of that?
Yeah, hold on. Yeah. And this will get more, and I'm gonna answer your question. Thank you, Professor B. I'm gonna answer your question in just a moment. I am all about terminology, guys. and you'll hear me cut up sometimes about it and get on you about it and make you find out what terminology is. What is the belt that we're using to climb up poles? What is that called?
The buck squeeze?
Buck squeeze, right. And what it is if you said buck squeeze, I know 100% anybody on a crew would know what you're talking about. And what I don't want to happen to you is you get on a job site and say, hey man, can I borrow your buck slide? Because somebody's going to say, what the heck is a buck slide?
Yeah.
Gotcha.
All right. So, don't think I'm harping on you.
No, no,
So you got your terminology, right? And obviously the cross arms is called a cross arm, not a crossbar.
Across.
All kinds of different stuff. So to answer your question, there is a lot of adjustment, and really you got to look at your pole before you climb it. Now you were on the one closest to the parking lot, which at the base looked just like the one that was to your right. And I think, who was it? Nigel climbed that one. All right.
Yes,
Yours tapered a lot quicker than his. His I would say had 50%, and we'll just call it this, more meat at the top. Okay. Well, as you got to the top, you were almost buckled. You're almost all the way that the buck squeeze could go.
Yeah.
Okay. Yes. All right. That's something you have to look at on your poles. Now, I told you yesterday, you climbed that I climbed those 125s at the waterway, but I had my belt all the way out, all the way, because the base of that pole is
Right.
bigger than that. And by the time you get to the top, it's about the size of a 35-foot pole. It's about that big around. So there's tons of adjustments.
Okay.
Scope your pole out before you climb it. Make as many adjustments as you need as you go. With that, and this is kind of strange on the 30-foot poles. Once you get up to the top and you're standing at the top of a 30-foot pole, it's this big around, and you've got that buck squeeze as far as it will go, right? Your green belt that's coming back this way has now got a lot of extra slack in it because it's so small at the top. That's where you're going to do the green side adjustment to bring you up towards your work, okay? There's just no more for the brown belt to go. You've used it to its extent. The green that's coming back to your belt is extended because you're so small. So you're going to have to adjust the side and get that squared away to bring you up closer to the pole. Does that give you a good explanation, Ryan?
Yes, sir. Thank you.
You're welcome. Good
Any more
questions out
questions?
there, guys. Good questions.
Yep, yep. Don't mind taking the time to answer them.
Mhm.
Talk to us about it. Okay. All right, gentlemen, if there's no more discussion about the video or climbing, we'll move right into today's work online here. Everybody got their math book?
Not yet.
I see a couple of them out there. All right, and guys, the start of this book is just kind of, I'll just say it's simple math. I'll be the first honest, math is not my strong suit. I'm not the best at it, but it's something that you will have to do some calculations out in the field going into the electrical industry. I'm not sure about telephone, but I'm sure there's some, mathematics involved in that as well, in the communication side of it as well. So, but anyway, if you've got a book, we're going to start on page 2 in unit 1, page 2. I'll give you
And I'll give it, while you're getting your books ready, I'll give you a disclaimer here. What does the book say? Practical problems in mathematics for who?
Electricians.
All right. Never compare yourself to an electrician. Electrical linemen and electricians are completely different people. These are the best books that we have that are out there in the world for electrical linemen. We don't teach in the electrician way. So you see some electrician calculations in there. We'll teach you in the lineman way. Okay.
But guys, we talked Monday as well when we talked about books and tools and all that, and talking about using a calculator, and You don't have to go buy those Texas Instruments calculators. Go to your smartphone, pull up the calculator. I know there's a bunch of apps out there for it, but I just use the basic app with my iPhone. But anyways, that's what I encourage you to do this morning. If you have one, you got your smartphone with you right there, go ahead and open it up, because I'm gonna throw some numbers at you here, and we're gonna do a little addition from starting at unit 1. Is everybody ready to roll on? We good? Thumbs up? Okay, all right. Page 2, unit 1. I'm just gonna read this first column right here, this first paragraph. Whole numbers are numerical units with no fractional parts. Addition is the process of finding the sum of 2 or more numbers. Whole numbers are added by placing them in the column with the numbers aligned to the right side of the column. The right column of numbers is added first. And if we do this, Professor Shoemaker's got his Wacom up. We're going to throw some numbers. So in the example, down below that column there's 25. Are you on there?
To me?
Yeah, I can't. Are you writing?
I am.
Okay, there's nothing coming across.
Yeah.
Yes.
It's
Yeah.
blank.
You don't see page 2, unit 1, 25?
Got a white screen.
It's white.
I got a white screen.
All right, hold on. Screen 2. No, let's not do that. Whiteboard. Share.
Okay, oh, there it is.
Okay.
Yep, there it is, 25. And then we got plus 7, plus 126, plus 54, plus 367. Okay, guys, in the book, it's going to show you lining them up just like he's writing it out now. 54 and 367, starting on the right-hand side. Adding all those numbers up, what do we get up? Get
5, 12, 18, 22, 29,
29, carry your 2,
4, 6, 11, 17.
79,
Here's the
okay.
number.
Yep,
1, 2, 3, 5.
579. Simple addition, guys, right? Everybody's good with adding that way. I know some of you guys that might be out of high school, last year or year before, and they really teach you. To me, I've got a daughter that's been out of high school for, a couple of years now, and some of the ways, especially coming up the way they were teaching them to add, I didn't agree with it. It just wasn't simplified for me. So anyways, I'm gonna go over to, and you'll see some of these, you're gonna see a problem similar to this on the quiz today. If you look at page 4, number 4, the very top question, it says an electrician uses switch outlet boxes on 8 different jobs. The number of boxes used on each job is 56, 9, 86, 36, 93, 105, 42, and 56. Find the total number of outlet boxes used.
Good grief.
Yep. Guys, anybody got their calculator can run those numbers up real quick?
43,
For what?
83.
483. Good job. Guys, and that's what it's basically going to be. You're going to see the question on your quiz today. It's going to be very similar to that, easy math. So I don't think you guys will have any problem with that. Anybody got any questions or comment about addition? Unit 1.
For our quiz, how do you want us to do it if we don't got a book yet?
It's gonna be on the
No, we've got a quiz in D2L for you.
Yeah.
Who was that asking that question?
Oh, that was me.
Adam.
Adam. Okay, Adam. Yeah, we'll go ahead and go through what we need to teach to you today. And we are online on Zoom after all the classes, at least till 4 o'clock. So it'll be presented in D2L. You bring it up, and you just answer them as you would type in one. Of course, you're able to use a calculator. It's a type in or we try to use a lot of multiple choice answers.
Yes, sir.
While we're going along here, before, I tried to jump in here before Professor V started. Guys, don't get in a rush on this, and double check your work, especially we've had a lot of students that start to use a calculator or a phone, throw in numbers right there, and then, give us a number as an answer. And it is just a simple keystroke, or, punched in a wrong number on their calculator. Double check your work before you carry on with business out there.
Okay. Good. Questions? That answer your question? Okay. All right, guys, like I said, we're gonna move through this book pretty quick. If we're done with addition, that simple addition, let's move on to unit 2. That's on page 7. And that's basic principles of subtracting whole numbers. Okay, it says subtraction is the process of finding the difference between two numbers. The smaller the two numbers is placed below the larger, keeping the right column of numbers aligned. Okay, and we've got two numbers here to look at. The first one is the larger number. We're going to subtract 432 from 768. Okay, we're going to put the larger number on top, subtract the smaller number. Guys, what do we come up with?
336.
336. Okay. Is everybody familiar with subtraction? That's simple subtraction. Does anybody have any questions?
Professor V and the rest of you, remember we have the chat function. If you're embarrassed to say anything out loud,
Yep.
use the chat function.
Chat.
We're
Yeah.
not going to call you out if we need to go over something.
Yeah. And guys, just whenever the Zoom's over today and you want to hang around, just don't, disconnect yet. Just stay with us and we'll answer your questions for you one-on-one or two-on-one. Okay. Practical problems. Let's look at the first. I'm on page 11, guys. In the book, the first page 11. The first question: an electrician removed from stock 500 feet of BX cable on Monday, 250 feet on Tuesday, 750 feet Wednesday. On Friday, 339 feet of cable is returned. How many feet of cable are used?
1,839 feet.
Okay, so if you're looking at my screen, he removed off the reel 500,
Yep.
250, and 750. So what did you do
1,500?
there? And then added back, subtracted from the 339?
Subtracted from the 339.
Right. Is that how you did it?
No, I just added all of them together.
Yeah.
Read that question again.
Okay, an electrician removes from stock 500 feet of cable on Monday, 250 feet on Tuesday, 750 feet on Wednesday. Now on Friday, 339 feet of cable are returned.
Okay. So
39.
How many
So
feet are you?
1,500 minus 339.
There you go. There you go.
1161.
61.
1161. Good
There
job.
you go. That's what I like to hear.
Yeah, guys, just when you see these questions on the quiz, pay attention to the questions. Read them out carefully. Okay.
Okay.
Any questions about that? About addition? About subtraction? Anything like that? Are we ready to move on to unit 3?
That's good.
What time is it?
It's that time.
Ready?
Yeah, why not? 8:35.
8:35, guys. Let's take come back at what, at 8:45?
Sounds like a plan.
All right. 8:45. Let's take a break. All right, guys. We'll catch another break here in a few minutes, shortly. All right, we're moving on. We did addition and subtraction, units 1 and unit 2. Let's move over to unit 3, page 14, unless you guys got some questions about the latter. Okay, Hearing none, let's move forward. This is basic principles of multiplication of whole numbers. Okay, and of course, we all know multiplication is actually a method of addition used when like numbers are added. Just like if in the example, if 4 5s are added, the answer would be 20. If the number 5 is multiplied by 4, then that will give you the product, which is 20. Therefore, 5 times 4 is the same as adding 4 5 times. Okay, or 5 4 times. So what we have is 4 times 5 is 20. That's simple multiplication. All right, when we multiplying larger numbers, first write the number to be multiplied, then write underneath the number of times it's to be multiplied. The following example is 247 multiplied by 32. So write the numbers keeping the units column aligned. So 247 times 32. So I don't know if this is still the way they do it in school, but 2 times 7 is 14. You want to carry your 1. 2 times 4 is 8 plus 1 is 9. And then 2 times 2 is 4. You're going to come over a spot and use 3 times 7, which is 21. Carry your 2. 3 times 4 is 12 plus 2 is 14. Carry your 1. And then 3 times 2 is 6 plus 1 is 7. And then we'll go to and add the columns together. 4 and nothing is 4. 9 and 1 is 10. Carry your 1. 4 and 4 is 8 plus 1 is 9. So your answer is 7904. Okay. Guys, is that the way you guys were taught to do it or used to doing it that way from school or?
Same way.
Same way? Okay, I'm not.
Same way.
Wow. Don't let, okay.
Yeah.
Yeah.
Same way.
Same way. Don't use that old cube math.
I know nothing about that. I've been out of school for too many years to even know what that is. Okay. And guys, if you don't want to do it on paper, of course, you're going to use your what? Your calculator. Use your calculator on the phone. Okay. Let's do one of these practical problems on page number 16, number 2. And it says here, a bearing on a large machine is tested over a period of 8 hours at a speed of 40,500 revolutions per hour. How many revolutions does the shaft turn in the bearing during the test period? Anybody want to give me an answer on that?
324,000 rotations.
Thank you. Everybody get that same answer?
Yeah.
Okay, good job. If you didn't, we can go through it. Go ahead.
Yeah, if you didn't, recheck your numbers.
Yep, recheck it. Okay. All
Are
right.
you able to reread that question?
I can. You ready?
Yes, sir.
A bearing on a large machine is tested over a period of 8 hours at a speed of 40,500 revolutions per hour.
Okay.
How many revolutions does the shaft turn in the bearing during the test period?
Okay. I just wanted to get that question down.
Sure.
That's good.
Thank you.
Yes, sir.
You know to multiply it.
Sir?
How do you know to multiply it?
By the terminology that they've got in there. And that's where you need word questions are kind of something that I tell the students, reread it fully. We've already had one instance where we kind of read it one way and interpreted another.
Mm-hmm.
All right. So Professor V, and this is, I'm gonna write it out, and you notice on the share screen, I'm writing it as he says it.
Yeah.
Is there another one, Professor V, that you can pick on there?
Let's go with, look at number 3.
So I'm gonna write as he speaks.
Okay, it says, find the total amount of power in watts for the 3 motors shown. Okay, finding the total power in watts.
So stand by. 3 motors.
3 motors.
Okay, go ahead.
1 horsepower equals 746 watts. Okay,
Hold on.
Yeah.
Horsepower equals how many watts?
746 watts.
746 watts. I'm gonna draw that off to the side.
Okay, guys, and guys, remember that number right there, because you will see this number, the 746 watts later. Okay, all right. The first motor is 5 horsepower.
5,
Yep. The second motor is 7 horsepower.
7,
The third is 10 horsepower.
10. So, I'm not reading the question. I'm just writing it down as he goes. So I'm starting to get a little bit of concept right here. You're soon going to be asking for the total amount of watts, correct?
Correct. That is correct.
So from what I've deduced thus far, he's given me 3 motors. That number really doesn't factor anymore, because he's going to be looking for total watts eventually. So I need to find out what my full horsepower is. 5 plus 7 plus 10.
Got it.
5 plus 7 equals 12,
22.
plus 10 equals 22. Okay, so that's my total number of horsepower in this question. Carry on, Professor V.
Okay, so what is our answer for number 3? How many total watts are we looking at?
We're looking at
746.
How much?
16,412.
That is correct. And how did you guys get to that number?
Let me
Just
discuss it
20
out before they go to that.
Multiplied the
Okay.
horsepower by the wattage.
It's 22 horsepower by times 746 watts, which is basically for every horsepower you got 746 watts.
Okay.
Right. And I'll discuss my way through that, because I know there's a lot of different. And guys, we've said this before. If you got a path that you want to take as far as getting a math problem done, and that path is not what I'm writing on this board or what Professor Vermelin does, but it still gets you the same answer as far as your math world and what you've been taught, go ahead with it. Okay, that's fine. Here's my deduction out of what he said. All right, the 3 motors really doesn't concern anything, because they're asking for total horsepower, which I've got. If 1 horsepower equals 746, really is 746 added together 22, here's the word, times. So it's 746 added together 22 times. Now that we're in multiplication, all I have to do is take the 746 and multiply it by 22. That's going to give you my final answer.
Yeah, that's what I did. Okay. Yeah.
Right. So whoever asked, well, how do you know when to do what? You got to watch the question and word it out. Sometimes, and it takes for me, I've got to word it out for myself. If 1 horsepower equals 746, how many horsepower is there total if I do that 22 times? And you see the word times. 746 times 22. Okay.
Questions?
Questions? Answer.
Okay. And guys, a lot of these questions you might see today, this terminology you see like horsepower, watts, power, all that stuff's going to come into play, in the next week or so. So just keep that stuff in the back of your mind. If you've got some paper down there and you want to jot down notes, that's good too. This is being recorded. You can go back and watch the recording, and it does have its own notes in there where it's transcribed, so you can go back and look at that as well. So any more questions about multiplication of whole numbers? We good? We
Use chat if you need to, you use chat.
Yep, use your chat box down there. Throw the questions out if you need to. And then if, if you do a little, something comes to mind and you want to do it in there, just, if we have to back up, we'll back up. Okay, if hearing no other questions about that, let's move into unit 4. Like I said, we're gonna blast through this stuff here kind of quick. Page 20, division of whole numbers. Okay. Give you a second. Okay, page 20. All right, in unit 3, it was shown that multiplication is actually the process of adding a number to itself certain number of times. Division is just the opposite or inverse. Division is actually the process of subtracting a smaller number from a larger number a certain number of times.
That would be my next question.
Okay, I thought somebody had a question.
Okay, mama.
The larger number, the number to be divided, is referred to as the dividend. The number used to indicate the number of times the divided is to be divided is called the divisor. The answer is known as the quotient. To begin the process of division, the dividend is placed inside the division bracket, and the divisor is placed to the left of the dividend. Okay, so you've got the divisor out to the left, then you've got the dividend within the dividend bracket where you're dividing into that, and then of course your answer on the top is the quotient. Okay. If you don't have a book, I'm gonna push this to the screen, and I want you to see where my finger's at. Where's my finger? See right there where it says that?
Yep.
That's how it's to be spelled out or laid out. All right, now the first example we have is 1,140 divided by 17.
I will give this little hint right here, and this is probably the most common error that we see in this thing. Punching this into a calculator, make sure you're putting the numbers in the right order.
Correct.
So what we'll see is a student do is he'll punch in, what were the numbers again?
1,140 divided by 17. 1,100, yeah.
Right.
Yeah.
That's how he'll throw it into the calculator. He will put in 17. He'll hit the divide key, and then he'll put the 1,140. All right. Is that the correct way to put it into your calculator? First enter, divide key, then the next number equals. Is that correct?
No.
No. Watch your direction of numbers here. The question is 1,140 divided by 17. That's how it's punched in the calculator. 1, 2, 3 equals. So watch out for your direction of entry.
Okay.
So do we want to do it the long way? 1,100 divided by 17. And I have to admit, division is not my forte. I don't like it that much.
Yeah. All right, if we're doing that, I'm using my calculator.
All right.
All right, so looking at that, the way I was taught to do it way back in the mule and buggy days, you're going to take this, you look at how many times the 17, will it go into 11? Of course, you say no, then you move over one spot and you go 114 divided by 17. How many times does 17 go into 114? Anybody?
6 times.
6 times. So you put your 6 on top.
Hold on,
above.
hold on.
Say it again.
How'd you get that number?
6.
Yeah, how did you deduce that? By calculator, by paper?
By paper.
Okay, okay.
So I usually I put 17 into 114. Obviously, it doesn't look right when you're doing it, but so I would take 17 times 10 and get 170 and realize I need to go lower. So I cut that number in half, at 5, and that gives you 85. So I add 17 to that, and that brings you closer to the number.
Okay.
Okay.
You're working it out.
You're working it out. That's what I want to hear.
Yep.
No, I'm not a math wizard.
Okay, so 6 times, so 6 will go on the top line up above the 114, right above the 4, because that's where it's placed. And so 6 times 17 was what again?
102.
102. So 102 goes up under the 114. And we subtract that. And that's going to give us, a what?
120.
A 120. Yes.
What did I do wrong?
I don't know. So you're going to get 120.
Oh, you borrowed to.
Yeah, where's the 8?
Gotta bring it. You gotta bring it. You gotta bring it more over. You gotta put it like directly under the 114.
That, I see what John. Okay, hold on. Carry on with business there, Professor B. I don't do division like this.
Okay, this is just the old way, mule and buggy days.
All right.
So we got 102 minus 114. That's going to give us 12.
And then you bring down to 0.
And then we bring down to 0 because 17 can't go into 12. So we have to bring it down again. So how many times is 17 going to 120?
7.
All right, put the 7. We put the 7 up above with the 6. So that'd be 67. And we subtract 119 from 120. And we get a 1. And so we have a remainder of 1. 67.1.
Yeah.
Okay.
So guess what I would do?
Use your calculator.
Yeah. And I'm old. Be totally honest, guys, that's not how I would do division, and I'm not going to put down on paper how I do it. It just confuse you more.
Yep.
Break out the calculator.
Break out the calculator, guys. Exactly. Okay. Guys, you got any questions about that? We can use, let's go to a word problem with that on page 22. Practical problem number 1. And it says, in a 184-foot run of BX cable, the staples are placed 4 feet apart. How many staples are used if one staple is placed at the beginning and one at the end of the run?
Oh my God.
And I know it, man. That's crazy. So you got to add that back into it.
And this is division?
This is division.
Can you give me that question again?
Okay. In a 184-foot run of BX cable, the staples are placed 4 feet apart. How many staples are used if one staple is placed at the beginning and one at the end? Okay. So we're going to divide, I guess, 184 by 4.
And you get 46, I believe.
46.
I believe. Let me double check.
Yeah, it's 46.
Yeah.
Okay, 46. So, and then we're placing one at the beginning and one at the end. What are we coming up with? Correct.
Plus 2, 48.
Plus 2. Correct.
48.
Read your questions carefully because it's asking you to divide 184 by 4 because they're 4 feet apart. Then it's telling you to add to it, one at the beginning and then one at the end. You're going to add 2 to that.
Oh, okay. I see.
Yes,
Yeah,
I
okay, I
kind
got
of
you,
see what they're
got you.
saying there.
Perfect.
So guy starts out with this table, and he puts a staple, he just starts walking 4 feet, puts a staple. That's how we're getting that part. Then you got to go right back. Well, when I'm done, I'm going to put 1 at each end. So that's the +2.
Okay.
Okay.
Okay. Questions, comments?
Yeah, you gotta make sure you read that wording.
Sure, that's exactly. Make sure you read it carefully. Okay. No questions in the chat box?
None.
Okay. You want to move on? We'll move on.
Move on.
Moving on to Unit 6. Okay, this is addition of common fractions. Measurement often must be precise and whole numbers allowed. One method of indicating quantities that are smaller than a whole number is that of using common fractions. There are 2 parts to a common fraction: the numerator, the number that is above the line, and the denominator, the number that's below the line. So you have the numerator, then you have the denominator. The denominator indicates the number of equal parts the whole number is divided into. The inch, for example, is often divided into 16 equal parts. The numerator indicates the number of parts used. If the measurement is 5/16 of an inch, it indicates that an inch is divided into 16 equal parts, and the length corresponds to 5 of these 16 parts. Okay. Now, adding fractions. Before fractions can be added, all their denominators must be the same. Then only the numerators can be added. For example, let's add all these together.
Professor V.
Yes, sir.
So I know you're on a run there. Are we going to jump 5? Unit 5?
Did we skip 5? We did skip 5.
No problem. And I'll catch this. You hold that page that you got right there. Guys, this is very simple. I'm on page 26. We have bracketed, and let me go by what we got as an example. 8 plus 7 times 4. When you have bracketed numerals, how do we do this math?
You take care of what's in the bracket first.
15 times.
Tim does.
Good. Okay.
There you go.
All right. If you have double bracketed questions, 8 plus 7 times 4 plus 7 times 6. Okay. Work left to right. So it's 15 times 4 plus 42. Okay. That's math we've already really had, multiplication and addition, but work your bracket question first. And if you have a double bracket question, work left to right. Okay. Professor V, go ahead and jump back to where you were.
Oh, sorry, guys. I went right over that. That was such a small unit.
Yeah.
But we are on page 32. We're talking about adding fractions, and it's talking about numerators, denominators, those things. And like it says here, we're down at where it says adding fractions on page 32 at the bottom. Before fractions can be added, all their denominators must be the same. That's the bottom number. Then only the numerator can be added. And then I'll give you these 3 numbers. You've got 1/16 plus 3/16 plus 5/16. Okay. And it said here all the denominators must be the same. So we got lucky here. All these are the same. So it says now that the only thing we have to do is add the top numbers together. So 1 plus 3 plus 5 is what?
9.
9.
16.
16. So 9/16. Okay. Anybody got any questions on that about adding common fractions? Just make sure you keep your denominators the same. Now, if you had 1/16, let's say, plus 5/32,
Go ahead.
All right, we got 30 seconds. How are we gonna add this together, guys?
Multiply the 116 by 2.
All right, that'll give us what, 32 at the bottom?
Yeah.
Hold on
And
a
then what
second.
do we do? What do we, if we've done that to the bottom, do we have to do that to the top?
Yes, sir.
Okay, so what did that give us?
2 30 seconds.
Okay, 2 30 seconds plus 5 30 seconds gives us what?
7 30 seconds.
7 30 seconds. That is correct. Just remember, when you're doing that, whatever you do to the bottom, you have to do to the top as well. Any questions?
Yeah, I want to do one more there.
Okay.
And if there are questions, go ahead and ask.
Yeah.
When you get in these ones that have numerator, not different denominators, a good hint, or something to look at closely is what's the largest number in the equation as far as denominator. So I'm going to go 1/32 plus 2 64ths plus 3/8 plus, golly, what's another good one? 5/16. Out of all these numbers right here, which has the largest number at the bottom? Numerator, denominator.
64.
Okay, great. So that's my reference number right there. How many times does 64, what's 64 divided by 4? Or what's 2 times 32? I'm working on
64.
64.
64. So 2 times 32 equals 64. Whatever I do to the bottom, I need to do to the dot. What's 2 times 1?
2.
2. Okay, that's 2 64s. This is 2 64s. All right. How many times will 8 go into 64?
8.
8 times.
Yes, sir.
So I'm going to make this 64. 8 times 3 is what?
8 times 3 is 32.
24.
24.
That's right.
And 16 will go into 64 how many times?
4 times.
4.
Times 64. What's 4 times 5?
20.
20. 2 plus 2 is 4. Plus 24 is 28. Plus 20.
48.
48 over 64.
Yeah. That's just a tips, tricks. That use the biggest number. And whatever you do to the bottom number, you got to do the top number. I had to do 4 times 16 to get 64. That means I have to do 4 times 5 to get 20. Okay, Professor V.
Okay. Guys, you got any questions about that?
Do we need to reduce that fraction or no?
Can we do another one like that?
Great. Yes, sir, we will. Great question there, Ryan. That is in the question that we put on. If our question says reduce, then reduce. If our question does not include reduce, do not reduce.
Okay.
Okay.
Nigel wants another one.
Okay.
Let's go. Let's see. We used an even number there. Let's see. Let's try an odd number. 2/3 plus 4/9 plus 3/18. That'll work.
Yeah.
Plus, we'll just go from there. So what's my largest number here, Nigel?
18.
18. So I'm going to put my 18 and my 3 down here. That can remain the same.
Yes,
Right.
sir.
How many times will how many times will 9 go into 18?
9 goes into 18. 8. Trying to figure that out now.
What's 18 divided by 9? Anybody?
2.
2. Okay. Whatever I do to the bottom, I had to do 2 times 9 equals 18. I got to do the top. What's 2 times 4?
Okay. Now I'm getting it. Okay.
8. Okay. Put my plus mark right here. 6 times 3 is 18. So I'm going to use 6 for the 2/3. 18. 6 times 2 is 12. Whatever I did to the bottom. I've got to do the top. 12 plus 8 plus 3
23.
over 18. Like I said, I didn't ask for a reduction here. Even reduction of fraction or even a reduction of whole number, which is this is going to turn into. If we don't specify that, you don't need to do it.
Okay.
You good, Nigel?
Yes, sir.
Everybody else good? Okay.
Solid.
Good?
Solid as a rock.
Good. All right. No other questions concerning that, common fractions? I'm very carefully going over and seeing we're at unit 7. From 6 to 7. Okay, that's page 42, subtraction of common fractions. And it says here, subtraction of common fraction is similar to addition of fractions. In both operations, it is first necessary to have common denominators. Once both fractions have a common denominator, the numerator of the smaller fraction can be subtracted from the numerator of the larger. Okay, the example they give right here is 5/8 minus 7/16. So we have to have the common denominator. So what's our common denominator here, guys?
16.
Okay, so what do we have to do to 5/8 to make it compatible with 7/16?
Multiply the numerator and the denominator by 2.
Okay, so what's that's going to give us?
10/16.
10/16.
Subtracted, we're going to subtract 7/16. So what's our answer going to be?
3/16.
3/16, correct. Guys, you got any questions about that? Pretty simple stuff. Just remember, when you're adding and subtraction common fractions, make sure that denominator is the same.
So the denominator is the same before you do anything.
Correct. Good comment right there, whoever that was.
Mr. Clark.
Good job, Mr. Clark.
Yeah, and just remember what you do to the bottom to get that number the same, you do to the top as well.
I'm gonna do a little something right here.
All right.
Where do we need to go here?
5/8.
All right, what do I need to do?
Times by 2.
All right, so that'll make it what?
10/16.
Answer?
-3/16.
It'll still be 3/16.
No.
It said once both you can number of the smaller fraction can be subtracted by the number of the larger.
Right, you got to look at the direction of
Oh, okay, I see.
entry here. You got to look at the direction of entry here. I've got 7/16. I got minus, which is negative. And this is it. 10/16 equals a minus 3/16. Okay, you got to watch out, and that's we're going to discuss this probably a couple more times. You got to watch the direction of the math. Now, I don't think we've got any questions in our quiz that'll trick you like this. But if you've got a larger number in subtraction, in fractions on this side.
Yeah, still do it the same way how you'll do it. Yeah, I got you.
Do it the same, but you're gonna be in the negative. Okay.
Mm-hmm.
All right, good deal. Carry on, Mr. V.
Okay. Any other questions from unit 7? Okay, hearing none, we'll skip over to unit 8.
This is a fun one.
Sir?
I like this one.
Yep. Basic principles of multiplication of common fractions. Okay, fractions are multiplied by simply using the numerators together and the denominators together. Multiply 5/8 by 1/4, 1/4. So 5 times 1 is going to give you what? 5. 4 times 8?
32.
32. Okay. Let's Do another example here, 4/5 times 15 over 32. What's our answer?
60, 32.
Easy.
Yeah. It should be 60 over all the ones.
160. 160.
Okay. I want to
60.
clear my screen here. Yeah, I'm going to clear my screen. Maybe this will help you out a little bit better as far as this is concerned.
So multiplication, we just multiply straight across.
Yep.
Straight across.
Give me that question.
Oh, okay.
Okay, 4/5 times 15 over 32.
What did I do differently there? Instead of one multiplication sign, how many did I put?
You put 2
Yeah, just go
straight across. Okay.
right there. You go. 4 times 15, 60. 5 times 32, 160. Done.
There's my answer. Sweet. This one's easy.
All right. Now, it also says here, the answers should always be reduced to lowest terms.
Uh-oh.
Yep.
Oh, Lord.
Let's reduce that down to the lowest terms. Okay.
All right.
We know that 2, those are even numbers. We know that 2 will go into each one.
Mm-hmm.
So, okay, let's break it down again. Keep going. So
1/10.
say it again.
1/10.
Okay, or we've got 16 on the top, 160 on the bottom. You said 1/10.
Yes.
Okay, how did they get that number in the book?
8 would work.
What number you got on the book?
That's 3/8.
3/8.
That's what it says. Okay.
4 times 15.
Cross reduction.
Uh.
I don't know anything about no cross reduction.
4 times.
Oh, it's saying
Whoa. I'm sorry, guys. Whoa. 4 times 15 is 60, not 16. There you go. I'm looking at it. Hold on. Let's rewrite this out.
Yep.
4/5 times, what's the numbers?
15 over 32.
15 over 32. That's where we're going wrong. 4
Yeah.
times 15 is 60, not 16 over 160.
Now
Let's
break
work.
it down.
You can divide by
10.
first to get started. Yeah. No.
What's our answers, guys? How'd you break it down?
How about 10 first?
First I did about 10.
yeah, it's 3. Yeah, you're right. Break it down
3/8,
by
yeah.
10. It's 3/8.
Yeah. So if you broke it down by 10s, that would be what?
Yeah, you can do it by 20s.
16 and then
It'll be
2,
6.
3/8. Yeah. That is correct.
16.
Somebody punch in their calculator 60 divided by 160. 60 divided by 160.
370. 0.375.
0.375, and that's plus 3. All right. I want to ask that question. I looked directly at the number and I just went straight to the 20. 20 will go into 63 times.
Yeah.
All right. 20 will go into 168 times.
Yeah.
Done. If you want to go by tens, that's a good plan.
I went by 10 and then it went to 616 and then I divided it by 2 and it gave me 3/8.
There you go. Going division down is sometimes the course I take too. So fine job. Obviously, once you get to a prime number, 3, and then that number at the 3 at the top, you can't go any further.
Mm-hmm.
Okay.
Okay.
Good job.
All right, let's do one more. Right here, it says when a fraction is multiplied by a whole number, the whole number is first changed into a fraction. This is done by placing the whole number over a 1. So we're going to multiply 3 times 7/12. Remember what it said. We've got
What the book is saying, put the 3 over. One.
That's right. Okay, so multiply that out.
21 over 12.
21 over 12.
Okay, now we've got to reduce that down into the lowest terms.
Okay, so 3. So 21. 7 over, what is it? 4?
Yeah.
Okay, can that be reduced down any lower?
Nope.
7 over 4?
No.
Yeah.
So what?
So how many times does 4 go into 7?
I guess once.
Once.
1. And what's left?
Oh, you're trying to get the, oh, let's see.
We're going down to the lowest now.
1 and 3/4.
1 and 3/4. That is your lowest number.
I hope we're not leaving anybody in the dust here, because that's not the direction I took.
It's not, but that's the same thing was in the book.
Okay.
Yeah.
All right.
The book don't lie. What number was that? Okay. How'd you do it, Professor Shoemaker?
Well, no. If everybody's by the book, I ain't gonna say it. I'll just keep my mouth shut.
Not everybody's by the book.
No. Go ahead. Stay by the book, and I don't want to throw confusion into it.
Does Nigel, you understand how we got to 1 and 3/4? You understand? You can write it on out.
If you could write it out, that'd be great.
Okay.
So I could see how you were actually reduced it a little bit. I mean, I kind of get it. But
No, I think I see.
Okay, just like we started out, 3 times 7/12. And it told, huh?
I'm listening. I'm sorry.
All right, that's fine. So we had to have 2 fractions there, right? So we had to make 3 times 7/12, 3 over 1 times 7 over 12. And that gave us 21.
21 over 12.
Correct. All right, so we reduced 21 over 12 to 7/4.
There you go.
And then,
That's just reduction. That's all that is.
Yeah,
Okay.
we did that by 3s.
Got you.
Okay?
That's what I'm missing right there. Okay.
All right,
How many?
now, we reduced it down even lower we divided 4 into 7 because 7 is larger than 4. And 7 into 4 goes how many times? 4 into 7 goes how many times?
only once.
Once, with how many left over?
3/4.
3/4.
Go
3 over 4.
slow down on that part, okay?
What you want to do?
Hold on one second. Go
ahead.
back to what you said. 7 goes into 4 how many times?
4 into 7.
Once.
One time. What's left over?
The remainder is
3 is left over. This number stays the same. 4. 4 goes into 7 one time. Bang. What's left over? 3. This stays the same. 4. There you go.
Questions?
I'm set on that one.
What was that, Nigel?
Oh, I'm good on that one. I appreciate it.
You man.
Any more questions or comments? Now's the time to ask. Appreciate you taking time to ask those questions, Nigel.
Yeah, man. Anybody.
Okay.
Hold on a second. I lost my share screen.
Yes, you did.
Whiteboard share. Oh, it's back.
Okay.
Okay.
Do we need to do any more of those? Multiplication of common fractions?
I don't think so. It is 9:31.
9:31, we ready to take a break?
Yeah.
Come back at 9:45?
Sounds like a plan.
Let's do it.
All right, let's do it.
Hey, Professor, I got a question for you.
Oh my goodness, we're on break, dude.
I won't take much of your time. I got to take my daughter to an appointment at 10:30. I can still log back in on my phone though. Is that all right?
Okay, just turned 9:45, so we are back. And Professor Fee is on the phone. He had to make a phone call. Hold on just 1 second. You're muted there, Professor V.
Yeah, I was trying to get my mouse over from my Wacom. It was stuck, but I'm
Happens to me all the time. Yeah, admit.
got it. Got it.
All right, so I just informed them we are on page 52, Unit 9.
52, Unit 9, Basic Principles of Division of Common Fractions. Anybody got any questions on Unit 8, Common Fractions? Nigel had some good questions on that. If not, we're going to move on. And remind me, Professor Shoemaker, when we take a break to discuss my phone call with you.
Yes, sir.
Okay. Basic Principles of Division of Common Fraction. Common fractions can be divided in a manner similar to that used by multiplying fractions. When dividing common fractions, it is necessary to invert, and just pay attention to that, to invert the divisor, the second fraction, and multiply. The same rules that are used for multiplication of fractions can then be followed. All answers should be reduced to the lowest terms, and there it's telling you to reduce it to the lowest terms. So let's start off by dividing 3/4, 5/8 by 3/4 as he has it written. So it says to do what? We've got to invert the second fraction. So from 5/8 to 8/5, and then we go into the the multiplication mode. We got to find a common denominator. So what's a common denominator between?
Not in multiplication.
Not, that's right. My apologies. My bad. So what's our next step on that? 3 times 8? 24. 4 times 5 is 20. All right, let's break that down even further.
20 will go into 24 how many times?
6.
20 will go into 24 how many times?
Oh, one.
One.
Once. It should only have one.
What's left over?
Or 20.
Right? Does everybody capture that? I want to slow down a little bit on that. 20 will go into 24 one time. Remaining is 4. Remember, this never changes. All right, but we've got the whole number, but we need to still reduce this fraction. Before going to 20?
5 times.
5 times. What's 4 divided by 4?
1.
1. There you go. 1 1/5. Sounds like we went a little bit fast. There was a kind of what do you call it, apprehension on the answer there.
Mm-hmm.
Let's try another one, Professor V. I want to clear this screen.
Okay.
Clear all drawings. There we go. Let's try 2 8 divided by 1/9. What's the first thing we need to do?
Invert second fraction.
Invert. Okay, 2 8 times 9/1. Go ahead and do the math there.
18/8.
18/8. You notice in the book, they start doing reduction in that first example right through the course of the equation. That confuses me. I'd like to go ahead and get the final solution right there, then do reduction from my final solution, not through the equation. So how many times will 8 go into 18?
2.
2. And what remains?
2.
2, right? 2 times 8 is 16, so there's 2 left over. Can this be reduced further?
Yes.
Yes. All right, so I've got 2. How many times will 2 go into 8?
4.
4 times, and how many times will 2 go into 2?
One.
1. Final answer.
One answer.
Sounds good.
Okay.
Carry on, Professor V.
Carry on. Any questions, guys? You got that? We're gonna roll on. Unit 10, basic principles of combined operations with fractions. This unit provides practical problems involving combined operations of addition, subtraction, multiplication, and division of common fractions. As with combined operations of whole numbers, a standard order of operations should be followed when dealing with combined operations with common fractions, okay? Number 1, do operation inside parentheses. Number 2, solving expressions that contains components or roots. Number 3, multiply or divide left to right, add or subtract left to right. All right, first example, 3/8, this is in parentheses, 3/8 plus 1/16 times 8. Okay, so first perform the operation in parentheses. The common denominator for 3/8 and 1 1/16 is what? 16. So rewrite that as what?
How many times? 2
What?
times 8 is 16. I'm working on the first number here.
Yep.
What's 2 times 3?
6.
So that makes that 6 over 16 plus what?
17 over 16.
You guess what? I'm glad you said that. You can go that route, or you can just leave it the whole number 1. So I'm kind of glad you said that. What he did, who said that?
Lucas.
Lucas changed 1 into 16 over 16. That is 1 plus 1 over 16. Okay, or you can just leave this number 1 alone. So let me clear the screen here. No, I'll come over to the side. Oh, whoa, 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 whoa. What happened there? I'll come over to the side right in this area on the right-hand side, or you can leave it as is. 6 over 16 plus 1 and 1/16. Okay, both of these will work simultaneously. So go ahead and let's do, what did Professor V say? What do we got to do first as far as the equation is concerned, the whole equation?
Parentheses.
Parentheses. So what's 6/16 plus 1/16? 6 plus 1.
7/16.
7/16.
Okay. And we still have the whole number of 1, correct?
Correct.
All right, 1 and 7/16. We've done the inside of the bracket. 1 and 7/16 times 8. The whole number.
$48 over 16.
How'd you do it? How'd you do it?
8 multiplied 8 times 7, and then 16 times 1.
I think they kind of backed out of how they do a process. This is
Do you
tough.
do you turn the 8 into a fraction? Put the
You can, or you can leave it as is. Or you can do both.
like I'll put 8 over 1 and then 16 and times 7 by 8.
Okay, so let me clear screen here. Remember 1 7/16 times 8. I want to clear screen. So it was 1 and 7/16. Sorry about that.
Yeah.
Times 8.
8. Okay. Here's the route I would take, guys. I want to take 8 and multiply it by 1. What do I get?
8.
All right. I'm going to change 8/1 into a fraction now. Correct? What's 7 times 8?
48.
56. All right. What's 6 times 1? 16 times 1?
It was 16.
16. Okay. Can this be reduced?
Yes.
Yes.
To what?
Probably 16 keep going, 56.
702.
And I know this kind of gets, as far as drawing it out, gets kind of weird. Here's what I'll do. I'll start going by numbers. 1 times 16 equals 16. 2 times 16 equals 32, still below. 3 times 16 equals 48. Dang it.
That's 3 times.
40. Why is that doing that? Oh, because I'm drawing up top. 48. All right. Once I go to 4, I'm going to be over the amount of this number. So it's definitely a 3. And that gives me times 16 is 48 minus 56. 48 minus 56 equals what? 8/16. Can this still further be reduced? 8/16. Can y'all hear me?
Yep.
Yeah.
Can 8/16 be reduced?
Yes, it can be reduced.
To 1/2.
1/2, right? 8 will go into 16 2 times. 8 divided by 8 equals 1. So the numbers I have left out of my entire equation are 8 plus 3, 1/2. What's 8 plus 3?
11.
And what's my remainder?
1/2.
What do we have on paper? See if I got this right. Holy cannoli. Look at there. I got lucky, guys. I got lucky. So really there in the long run, for part of the fraction, I had 1 7/16 times 8. I left the 8 whole and took 8 times 1 is 8. Now that I've got a fraction I need to multiply it by, I converted it to a fraction. 8 times 7 is 56. And 1 times 16 is 16. I did reduction on this number, which gave me 3 8/16. And then I reduced 8/16 down to 1/2. 8 plus 3 1/2. 11 1/2. Yeah. Is it lunchtime?
E.
All right, go ahead, Professor V.
Okay, guys, any questions about that? You want to do another problem?
No.
No?
Let's run another one like that.
All right.
Go ahead.
Let's get to it. I don't like word problems. I'm just going to draw one out. What happens here?
Sure, please do.
I'm just coming off the cuff with a problem. So let's try. Let's see if we get something similar here. Let's try 7/8 plus 2 1/4 times 3. Is that looking right? That's looking close to the same equation that we had right here. So first thing we need to do inside the brackets to be able to do the plus is get the common denominator, correct? All right, so let's do that first. What's the common denominator between these two?
8.
8. All right. 2 times 4 is 8 here. So I need to do 2 times 1. So I'm going to go 7/8 plus 2 and 2/8. Okay, so now we're able to do that. All formulates out good times 3. So what did I do before in the previous equation? All right, let's go ahead and do the math. We got to do brackets first. 2 7/8 plus 2 2/8. 7/8 plus 2 2/8. So I'm going to take 2. That's my whole number. 7/8 plus 2/8. What is that? 9/8. Oh, good. We get to reduce inside here. What does that reduce to? How many times will 8 go into 9?
9. I mean 1.
One time. All right. What's left over? 1 1/8. 2 plus 1 equals 3. Right here. 3 1/8. That's my final solution for the bracketed problem. I'm going to draw that over here.
Yeah.
3 1/8. Okay. This is where I kind of deviated from the book a little bit. All right. 3 times 3 is what?
9.
9. Okay. Now that I've got a fraction, I've done this one already. Check. Now that I got a fraction, I'm going to convert this one to a fraction. What's 3 times 1?
3.
3. And what's 3 times 8? Excuse me, 8 times 1?
8.
8.
No. Yeah.
Finish. There's your
Fine,
solution.
I'm second guessing myself.
There's your solution. Good? I can guarantee you guys on a quiz, we're not going to crush you with something hard. That's for sure. All right, Professor V.
Carry on.
My wayward son. There'll be peace when you are done.
Okay, well, I certainly hope so. All right, guys, if there are no further questions about Unit 10, I will add one to that and make it Unit 11, page 60. And we're going to go into addition of decimal fractions, okay? All right, one of the advantages of decimal fractions as compared with common fractions is that when decimal fractions are added or subtraction, it is not necessary to find a common denominator. Adding decimal fractions is accomplished by placing the fractions in a column with all the decimal points aligned. The columns are then added in the same manner as whole numbers are added. All right, if you got a book and you're looking at the bottom of the page here, and then you'll see it's got like millions, then a decimal point, and then you've got tenths. It goes in reverse. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, and millions. Professor Shoemaker, can you demonstrate that on the board?
I'm sorry.
That's all right. Can you put 7 zeros and then point and then 6 zeros?
7 zeros. 1, 2, 3, 4, 5, 6, 7.
Okay.
There's my point.
Yep. And then 6 more.
1, 2, 3, 4, 5, 6. Go ahead.
Okay. Starting on the left-hand side, of course, we know that's the millionth spot. Millions, and then we go 100,000s, and then we go 10,000s. Then there's thousands, hundreds, tens, and then the ones. Okay. Then we have a decimal point, and beyond that is the tenths, hundredths. Then you have thousandths, 10,000ths, 100 or 100,000ths.
Good grief. 1, 2, 3, 4, 5. Right. Yep.
100, and then the last one, of course, is millions.
Okay. Yeah, you get the.
And guys, I'm gonna tell you what, we'll never go that low on any equation. Usually, we'll go to the tenths or the hundredths, and maybe sometime to the thousands. But most of the time, we're gonna round it down to the hundreds. Okay, not unless you're got some equation somewhere where you're going to work and they want it down to infinite numbers. That's what you'll do. But we're concerned with tenths, hundredths, and thousandths in our equations. Okay. Let me give you an example here. Let's look at the example. We're going to add these numbers in. Okay. Ready? 4.0563 plus 0.98.
Take your time on me, please.
I am.
And to help me out, if I'm doing this on paper, to help me out, I go ahead and add the extra zeros. So I can keep The thing is, you want to keep the decimal lined up.
Right.
Well, to help me out on numbers, I want to keep the numbers lined up. I'm going to put 0, 0 over here. Go ahead.
Right. We're gonna add 14.0008
Perfect. Go ahead.
plus 0.4005 plus 10.33.
And like I said before, to keep my stuff in order, I'm going to add the 0, 0 to the end.
Correct. All right, guys, you want to start on the very right-hand side and add those up. And of course, it's going to be a whole lot easier just whipping that stuff in a calculator.
Ooh, I wonder if I was quicker than anybody else.
Yeah.
Oh, look.
Am I right? Dang! He's a,
7676. Yep. Now, when all this was added, of course, it was down to the thousandths, or is it 100,000ths?
100,000s, tens of thousands.
Tens of thousands. So most of the stuff we give you on quizzes won't be that low. We're not going to ask for, I don't think, anything looking at the quiz that it'll go that low, or maybe it will.
I don't know if anybody heard me talking under my breath there. I'll get it, I think. I was kind of talking under my breath during the equation and going down doing my math, speaking out loud. Did anybody notice that when I got down to the bottom here, I had 2, 9, 7, 6, 7, 6? That's what I had. But me keeping everything in order, top to bottom, all I had to do is drop my decimal down. That's where I knew to throw my decimal, is because one thing that helped me out was putting the zeros at the end of these numbers. And then I had to just went straight down and drop the decimal down to where it's supposed to drop in the equation for the solution. Okay.
Questions about that, guys? Decimal fractions addition. Okay. Hearing none, no messages on the chat, so I'm going to head on to page 66 and add another one to unit 11, which will be unit 12, page 66, and that's going to be subtraction of decimal fractions. Okay. When decimal fractions are subtracted, the smaller number is placed below the larger number with the decimal points aligned, just like Professor Shoemaker did. The procedure is then the same as that used in subtraction of whole numbers. The decimal point in the answer is aligned with those above it. So our example here is 12.349 minus 8.907. Smaller number up under the larger number.
And I aligned my decimals.
Line in your decimal. Keep them in line. Simple stuff.
2, 4, 13 from 9 is 4, borrow on 11 threes. Eliminate is 3. Bam.
Okay. Everybody got the same answer? 3.442. Questions? Okay. Professor Shoemaker, you got anything else about that? You want to do another one, or are you good with that?
No, unless they want to.
Okay.
Oh, real quick, what'd you do with that 3?
What I do with that 3?
Wrote
You
it
borrowed,
This one right here?
no, the one on like 12.349, like it's 3 minus 9. How'd you do that?
Okay. Hold on.
All right.
I'll
Good.
go through it slowly. I know I did it in my fashion. Remember the numbers, please.
Got them.
All right, give that to me again.
12.349 minus 8.907. 8.907.
8.907. Okay, I'll talk through and use my mouth instead of my brain. 9 minus 7. 2. 4 minus 0. 4. 3 minus 9 will not work. Okay, I've got to have a number like 9 is higher than 7, 4 is higher than 0. So what I can do is I can borrow from the 2 and 12, and I made this 13.
Okay.
Yeah, there you go.
13 minus 9 is 4. Now, some people would probably step ahead because I borrowed, that made this 11, and it's the same 11 minus 8, but I'll just stay in the column. Okay. 1 minus 8 won't work, so I've got to borrow from here too. Now I've got 10, excuse me, 11. There's 1 already there. Now I've made it 11 because I borrowed this number over here. 11 minus 8 is 3, 3.442.
Okay.
Okay. Good question.
Any further questions? Hearing none. Going once, going twice, gone. Here we go. Moving up to Unit 13, page 70. Guys, anytime if you think about it and you want to ask questions concerning something we've already gone over, just throw it out, okay? Multiplication of decimal fractions, okay? Multiplication of decimal fractions is the same basic procedure as the multiplication of whole numbers. When decimal fractions are multiplied, the number of places to the right of the decimal point in both numbers must be counted. The same number of places must appear to the right of the decimal point in the answer. So our first example is 8.650 times 3.5. 8.650 times 3.5. Okay. Okay.
I'm sorry. That's sloppy.
I'll fix it. That's a little different. 8.650. Yep, times 3.5. Now we're cooking with Crisco.
Thank you.
Okay, so let's multiply that like we would any number. 5 times 0 is 0. 5 times 5 is 25, carry your 2. 6 times 5, 30. Plus 2 is 32, carry your 3. And 5 times 8 is 40, plus 3 is 43. And then let's go look at the top. The other number, 3 times 0 is 0.
Watch this real quick, guys.
Bring it over.
Yeah, I know. You see my alignment right here. 0, 5, 0. Now that I've moved over to the 3, I'm going to go 3 times 0 equals what?
0.
0. What? See, my alignment has changed.
3 times 6, 18.
5.
Oh, 5, I'm sorry, 15.
15, carry the 1.
And 3 is 16. 18 and 19, carry your 1.
19, carry the 1.
3 times 8 is 24, plus 1 is 25. And let's add those together, starting at the right.
You can put a 0 right here because it's an empty space. 0, 5, 7. 3 plus 9 is 12, so I'm going to carry 1. 4 plus 5 is 5. Excuse me, 4 plus 1 is 5. 5 plus 5 is 10, so I'm going to carry another one. 3. Who can tell me, now how do I figure out the decimal places?
You add them together.
So you add the amount of decimal places I have in this one with the amount of decimal places I have in this one.
Mm-hmm.
So 1, 2, 3, 4.
Yeah,
That's it.
That's
it.
right.
I've got 3 decimal places in this one. I've got 1 decimal place on that. So I start at the end of the number. 1, 2, 3, 4. Bingo. That's where my decimal goes. 30.2750. Am I right?
Correct.
Hey, sweet.
Sweet it is.
You on fire.
Okay. Guys, was that simple enough?
Mm-hmm.
Oh yeah.
Any questions? You want to do another one? Or you want to move on? Okay. We're going to move on. All right. That's another fast unit. We're going to go jump up to number 14. And we're going to talk about division of decimal fractions. And it says, when decimal fractions are divided, divisor is placed to the left of the dividend in the same manner as division of the whole numbers. When dividing decimal fractions, however, the divisor must be a whole number and not a fraction. The divisor can be made a whole number by moving the decimal point all the way to the right of the number. When this is done, the decimal point of the divided must be moved the same number of places to the right. The decimal point of the dividend, is then placed directly above the division bracket. The numbers are then divided in the same manner as whole numbers. So let's look at 19.44 divided by 3.6. Okay.
So by the rules that he's telling us right there and the instructions that we have the book, the one that I've got the arrows to right here must be a whole number. So you've got to convert that decimal. We got to move that decimal over 1 to make that a whole number. That makes it 36. Whatever we do to this number decimal wise, we have to do to the same to this number right here. So I'm going to move the decimal over 194.4. Okay, go ahead.
All right, let's figure that out. 36 into 194.4. How many times does 36 go into 194? Because it can't go into 19. It's got
5 times.
5 times.
5 times. So 5 times 130, excuse me, 5 times 36 equals what?
180.
180.
180.
180.0.
How many's left over?
4 minus 4, 9, 14.4. 140, 14.4, excuse me.
Okay. So 36 into 144.
Let's see, that will go
4 times.
4 times.
4 times. Okay.
Right.
So we've got a 5 up there above the 194.
Oh, that's perfect. That's
Yep.
perfect.
Perfect.
Yeah.
So our answer is going to be what?
5.4.
5.4.
Correct.
Good job. Everybody got that?
Excellent.
You want to study on that a second, or you want to move on?
I want to. What I
You do another one of those.
We can do another one of those.
Yeah, sure.
Okay.
Clear that screen. Sorry about that. Clear all drives. Professor V, just give me something. What do you want to do here?
Let's see, 20.54 divided by 2.4.
20.54.
Yeah.
0.54 divided by what?
Let's go 2.4.
2.4.
Okay.
Okay. So rules wise, I've got to convert that to a whole number. So I'm going to make that 24.
24.
All right. When I do something on this side, I move on this side, I've got to move on this side. So that makes that 205.4 divided by. All right, let's throw it into the math. 24 divided by 205.4 divided by 24. All right. So how many times will 24 go into 205? 8 times 4 is 32, 16. Ooh, 8's looking like a good number.
Divided by 24. 8.5.
Yeah, about 8.
8. Okay. 8 times 24. 8 times 4 is 32. 8 is 192. 192, 0. Okay, and what's remaining? 434. Correct?
Yes, sir.
Oh, hold on. 10 minus 9 is 134.
1.
1. Okay, and then with 1 minus 1 equals 0. So we have 134 to divide by 24. What's that number?
Got him.
Okay.
I think.
Yeah.
134.
5 times 4 is 20. 5 times 2 is that's 120. 6 times 4 is 24. That's too far. So it's simply going to be a 5.
5.
5 times 24 equals, let's see, it's 120. 1, 2, 0. 14. And we can't go any further, correct?
Right.
Yeah.
So we got 1 decimal. 8.5. And is there a remainder?
14.
Yep, remainder of 14. We can't go any further right there.
Correct.
Remainder of 14. There you go.
Okay.
I hear you talking your way through it, so it sounds good, Nigel. All right. So what time are we holding here?
10:21.
Have you looked? I'm sure you have, Professor V. You looked at the quiz, right? We are beyond what we need to have for this quiz, right?
Yeah, we're right at it. That's correct. Other than the fractions into a decimal point.
We need to do that now.
That's on the quiz, yeah, the
All
first
right,
one.
let's go ahead. Let's go ahead and go to it. That's simple.
Okay. What is the decimal value of a fraction? Um,
77.
What unit is that?
15, page 77.
Okay, let's look at that. So, all right, a simple way of determining the denominator of any fraction is to place a 1 to the left of the decimal, then place the same number of zeros in the decimal fraction to the right of the decimal and remove the decimal point. In this example, the decimal fraction point is 0.00450 is given. There are 5 digits to the right of the decimal. Write the number as described. Okay. I didn't quite get that, but
I don't like the zero concept right
I
there.
don't either. I don't either. So let's just go down to the example, express 3/8 as a decimal. And really that's pretty simple. What you're going to do is divide 3 by 8.
This is where you got to watch out for direction. It's not 8 divided by 3 as written.
Right.
To find the decimal. Punching it in my calculator, I'm going to put it in my calculator. 3 divide key 8 equals. Punch that in, let me know what you get.
0.375.
There you go. 0.37. Okay. I can guarantee you, I mean, we can go through the written math. Throw it in the calculator is a speedy snap of the fingers way to do this, to convert a fraction to a decimal. Let's try another one right here, not in the book.
Not in the book. How about
I got it right here on screen. 4/5.
4/5? Where?
Four divided by 5 in the calculator equals.
0.8.
0.8.
Okay.
There you go. Perfect.
Okay.
Now you guys got it down. All right.
We got that. We got that. We know how to reduce fractions to the lowest terms, correct?
Correct.
Yeah, we know excuse me. We know reduction.
What's the next unit? We need to,
Percents, averages, and estimates.
that's where we need to go next.
Today,
Yes. Then- Combined operator. Is that, which unit is that?
section 4, unit 17.
Unit 17. All right. Yep, and I think that'll be a good stopping point because I think that'll be the last quiz. That'll be the last part of the quiz we'll need to know for today.
Okay.
All right. Percent means hundreds. A number per 100, a number written as the percent sign, which takes the place of 2 decimal points. Okay, so what that means is whenever you see a percent sign after a number, that means that takes the place of 2 decimal points, is basically what it says. To change a decimal fraction to a percent, move the decimal point over 2 places to the right, multiply by 100 and add a percent sign. So express 0.40 as a percent. And what's that going to give us?
40.
40%.
And to help you wrap your mind a little bit around this more, based on what Professor V had said, as far as the tenths, hundredths, thousandths, was at 0.40. What position is this in? Tenths, hundreds, or thousands?
Yes.
Okay, so really, it's 4 times 10 equals what? Excuse me on the math.
40%.
4 in the tenths position is 40%. Watch this. 0.040. 4 times 100. 4%. Okay. I think the simplistic way to think of this thing, especially when you have a number that you come out with, is just what the book is saying. Move your decimal place how many points?
Twice to the right.
Twice. Exactly. Twice. Okay, Professor V.
All right, guys, and you may wonder why percentages? Why do you need to know about percentages? Well, let me put it to you this way. In the utility industry, when you go work on a line crew, if you go to work for a cable company, you get a work order and it has a certain number of jobs on it, you may get, a stack of work orders for the day and you add it all up and you get the number of conductor needed for all the jobs you're going to need that day. Well, when you plan for those jobs, do you roll off or do you bring the exact number of conductor that is needed for that job? Say it again.
Or
Whoever it is breaking up. So I'll go and I'll throw some numbers out there per Professor V's question. So we've got 4 work orders and we need some wire. One work order has 50 feet. One work order has 170 feet. One work order has 32 feet. And one work order has 650 feet. Add those all together. I get 802. 802. Is that what everybody gets?
902 I got.
902, I probably didn't carry. 902. So I've looked at my work orders and I got a final number of 902 feet. Professor V's question is that how much am I going to load onto the truck or do I need to take more?
I would take more.
How much?
I don't know. Not too sure.
Okay, that's okay. Professor V, what do you think?
Normally we'd like to go 10%.
Yep.
Hit it up with 10%, guys. And I mean, you can do it by the work order or total. 10% each job, 10% of the total, but you don't want to be out there and get to the job and be, shorthanded on wire, because you do that and it's going to be a bad day for you because you're going to get fussed at by your supervisor.
Right.
Mhm.
So I've got 902 feet. What's 10% of 902?
90.2.
90.2. Okay. I really wouldn't worry about the 90.2. So what you did, because we had 10%, you just moved over one, correct? Now it's
Yeah.
90.2 plus 902. And I'm not worried about the 0.2 because we're rounding right here. So we got 992. Now, what the heck? I'm going to pick up 1,000 feet.
Yeah.
There you go. Nice round number. Looks good on paper. The thing is, you got to definitely make sure you add. This is the big part. Don't walk out of that service center with the exact 902 feet, because I can guarantee you, when you do this last job right here, you're going to come up short.
Guys, you got any questions about that? You may see a similar question to that on the quiz.
Uh-oh.
Uh-oh. Any questions about anything we've gone over this morning? We've, hit you with a lot of stuff this morning. Any questions on anything?
The percentages was the last one for the quiz today.
Yep, that was unit 17. That's where we're gonna stop today. And,
I'm gonna fill it up till 11 after a break here.
okay.
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 So yeah, let's take it's 10:32 now. We're gonna run to 10:45 on a break. And for the last 15 minutes, we'll come back and I'm gonna start talking a little bit about electricity.
There we go.
See you guys in a few.
All right.
All right. I know we are in ELW 110, and that is math only. I'm going to show you some stuff here you're going to see again multiple times. But as the further we get up into math and the math portion, you're going to need to know information about electricity itself to be able to solve the equations. So that's why I'm including this today. And like I said, and you'll see right here, it's not on the quiz today. This is for note information. It's something you can refer back to as far as the video is concerned. So what are V volts? What are A amps? What are R resistance? And what is P power? I like to use the simple analogy here because can you see electricity?
No.
No. Can you feel electricity?
Yeah.
Well, yeah, but in the wrong way.
Yeah.
It's more of an invisible thing out there in the world that you really can't put your hands on and wrap your head around as far as, well, how does it work? How does it flow? What's going on? But in a water line situation, we know how those things work. So I'm going to draw a water line. Okay. And I'm going to cap it off here at the end. All right. And then I'm going to put me a nice little 2 horsepower water pump down here. And I'm going to pump water into my water line. All right. As soon as I start my pump up and I'm pumping water in my water line, what happens to the water? It fills up the pipe. What happens to the water? Is it pressurized? Am I pressurizing? All right, so I'm pressurizing the water in the pipe. Gentlemen, that is volts. As soon as I apply electricity to a wire, I'm adding electric pressure. excuse me. Okay, volts equals electric pressure on a conductor, just like a water pump puts water pressure on a pipe. All right, watch what I'm gonna do next. I'm gonna take the valve, I'm gonna take the cap off the end. Now I have flow. I'm pumping water in, my pressure's still there, and I'm putting water out of the end. Gentlemen, that is amps. That is the flow of electricity. All right. I've also got the value of R and power here. R in this situation is very, very minimal. Can anybody guess what I mean by R, the resistance? So I'm resisting the flow of water. What in this situation right here is resisting the flow of water in my water pipe?
The pipe itself?
The pipe itself. Okay, that's one portion. Think of this, Nigel and Ryan. The sides of the pipe itself are providing friction plus the size.
Oh, yeah. Okay.
Plus the size. All right. If I've got a big water line, it's going to provide less resistance to the flow. If I've got a small water line, it's going to provide more resistance to the flow. My flow hasn't changed. I've still got the same motor over here. The flow out hasn't changed, but my size has changed. That offers more resistance. Perfect. Great, gentlemen. So you're putting these things right together. Okay, power in watts. Where in my diagram of my water line here is the power? I've got generation. I've got volts, that's the pressure. I've got amps, that's the flow. What is power?
Whatever's coming out of the end cap.
You're very, I know where you're headed right here. Okay.
Water? Well, no.
It is. You guys are hitting on it real close. Okay. Power is the consumption. Okay. Power is the consumption of whatever's coming out of the end of the pipe. So if I put what do you call those things? Those wheels that water falls on?
Mm-hmm.
A water wheel.
Turbine.
Yeah, that's fine. If I put a turbine right here and my water flows over my turbine and my turbine rotates, am I now using power? Am I now making power?
Yeah.
Yeah.
Okay. So that's simple. In simple terms, that's it. Volts is the electrical pressure on a pipe. Amps is the flow of electricity down my pipe. Power is the consumption, and then we'll say this is at the customer side, the consumption of what is coming out of my pipe. I'm going to, excuse me. I'm going to clear all this real quick and then put it in electrical terms. Clear all drawings. Okay. So now I'm going to put a generating station right here. Power plant. Okay. Then I'm going to put my conductor out here, comes to here, goes through some woods and whatnot. All right. When I apply volts from my generator, I now have pressurized my conductor. And we'll just throw a nice, easy number out there. 7,200 volts. Okay. Now I'm going to attach my house to it. Bang. I'm going to turn a light on my house. As soon as I turn my light on, now I have flow, and that's measured in amps. Electricity is now flowing. Same pressure remains, but now I have amperage flowing. Okay. In the conductor itself, Is there resistance in the conductor?
Yes.
I'm glad you answered yes. Why do you say yes?
Would it
Just
be
like
at
the
the angles?
analogy you gave us with the water pipe, you have the sides of the
Size
inside
is
of
the
the
factor.
conductor.
Size is a factor. Nigel, what was your input there?
I put the angles that it's at.
Guess what? I mean, you're way above and beyond what we need to know as far as ELW, but turns in a conductor do
Yeah, they do.
make resistance. The one answer I was looking for here is, gentlemen, out there in the world, there is no perfect conductor. Right?
Yeah, type of conductor.
Yeah, even though it does conduct, there's no perfect conductor end to end. Everything has some portion of resistance in it. It's a very good conductor, but it's not perfect. There's actually resistance in the conductor itself.
Yeah.
In wire. Size and resistance in conductor. Okay. Remember me turning my light on in my house?
Yes, sir.
What do you think that portion is as far as volts, amps, resistance, and power?
Oh,
That's the power side.
Say power.
Yep, that's me consuming electricity. Down here at this end. One, that light bulb is giving off heat. Okay, and it's giving off light. So that's my power consumption. That's short and sweet, isn't it?
Yep.
Okay, we're going to be going over that multiple times, and there's multiple factors that are going to factor into this. But I always like to give that analogy right there that, well, Professor Shoemaker says something about volts. If I put a pump on a water line and I apply pressure, bang, you got it. Volts are electrical pressure. Okay. As soon as I open that spigot at the other end, flow starts, amps. There you go. I've got flow going. Now I've got amperage flowing. Well, you know, the pipe's only that big. Resistance. Okay. And then I've got on the end of my water line, I'm spraying my car down with a pressure washer. And obviously pressure's hitting the car. That's the power in watts. Any questions there? I like to give those little tidbits of information because they do come up multiple times later on in the course. All right, so what time are we holding there, Professor V?
we're looking at 10:55.
Dude, we are on fuego. The D2L quiz will come up, and like I said, we will text when it's available. I will let you know that you noticed it takes some time for the videos to convert on this end, then upload, then convert on YouTube. So those take a little time. I would suspect we're going to have the quiz open here right around 11:10, 11:15. Once again, we'll send you a remind to let you know when it's available. The video probably about an hour, hour and a half later. It will close at midnight tonight. Now we've got our quizzes set up to where they auto grade. And Professor V, you did check this is all multiple choice?
That's correct.
Okay. They're all multiple choice. So you're going to get a grade automatically. And you should be able to see that this afternoon. It will be observable by you. Professor V and I talked outside. This is kind of a litmus test of the first quiz of actual work that you're going to be doing in class. If things are looking good today and the quiz looks good and we get good interaction between you guys, and like I said, we're on until 4 o'clock this evening, we're going to climb Friday, Thursday and Friday. All right. If it looks kind of sketchy and you know needs a little work, we'll discuss that after. But as it sits right now, what I'm trying to tell you is don't jump in this quiz and say, bam, 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 I'm finished, and get a 50 because you didn't check your work. Take your time. You've got until 12 o'clock tonight. You can start the quiz, go to lunch, come back, resume, get a drink, go watch some TV, okay? Resume until midnight tonight. Don't close the quiz out until you've done it completely. Take your time while doing it. Set aside some time, okay?
How many questions?
V, 25?
Yeah.
10.
10.
Oh, Lord. Sweet.
10.
Bless.
Yeah, 10 questions, but bam. Okay.
Alrighty.
You know, one, a little incentive there. If this looks good today, Friday's climbing. If it doesn't look good today, Friday might be in class. Yeah. And the other part is, and I've seen it happen before to students, that's why I emphasize it so much. They, I got this knocked out, man. They don't check their work. They actually put the wrong answer in the wrong question. They skip one by accident. Take your time, recheck your work. Everything will be good to go. Any questions? Gentlemen, Professor V, unless you have anything more to add?
I do not.
Gentlemen, have a great day. We will be on Zoom until 4 o'clock. If you're having difficulties taking the quiz just from the D2L aspect, let us know. If you have questions about the questions, let us know. We'll be here for you. Have a good day.
Thank you, gentlemen.
Sir, you too.
All right.
Thank you. Have a good day.